Hello, welcome to Madam YY channel. Today we are going to learn about the preparation of alkenes. So alkenes can be prepared by elimination, and there are two methods to prepare alkenes. So first is dehydration of alcohol. It means that H2O is eliminated from the alcohol compound. And the second, we can prepare alkanes through the dehydrohalogenation of haloalkanes. Means that one hydrogen and one halogen is eliminated from the haloalkanes. Today, our lesson, we are going to focus just on the dehydration of alcohols. So in this topic, you need to learn how to write the products from the dehydration. So we start with the reactant, which is our alcohol. So under the condition of concentrated sulfuric acid or other strong acid, and when heat and reflux is present, the H and the OH can be eliminated. The H and the OH from the alcohol will be eliminated, and then we will get the double bond, which is an alkene. Then the byproduct will be water. So next, let's look at the example how we can remove the H2O from the alcohol. So we are going to remove one hydroxyl group and one hydrogen. So the hydrogen is normally next to the hydroxyl group. So we have one hydrogen atom which is next to this hydroxyl group, or the hydrogen on the top or the hydrogen on the left also can be removed. So it will be the same, we will get the same product. Either we remove this hydrogen, this one, or this one. So under the condition of strong acid and heat, so we will get the alkene. And then the next one, the cyclopentanol. So we have the OH, and then we want to remove another H. So the H that will be eliminated must be the next to the carbon, which is connecting to the OH. So we can remove this H here or another H on this side. So under the dehydration, the OH and the H will be eliminated, and we will get the cyclopentane. So sometimes the dehydration of alcohol, we might produce more than one product. So here come the Sage's rules, which is important to tell us which one is a major or minor product. So in an elimination reaction, the major product is the most stable alkene, which is the most highly substituted alkene. So what it means by most highly substituted? So you can see this is my alkene. Okay, my carbon-carbon double bond. So if the carbon-carbon double bond is directly connected to another carbon, so that one is considered as a substitution. So if you look at this first structure, the carbon-carbon double bond is only bonded to hydrogen. So this one we say there's no substitution. And then the next structure, we have one carbon, and the next one has two carbon, and the next one, the carbon-carbon double bond is the carbon is directly connected to 1, 2, 3 carbon, and then this one is carbon. So this one is considered as a highly substituted alkene. So as the substitute increase, the alkene will be more stable. Okay, so next we are going to see in certain alcohol might produce more than one alkenes during elimination. So for example, 2-chlorobutane, I'm going to eliminate one hydroxyl group and one hydrogen atom from the compound. So I can either eliminate the hydrogen from the third carbon or the hydrogen from the second carbon. So when I remove the hydrogen and the OH, if the hydrogen is removed from the third carbon, I will get 2 butane. And if the hydrogen is removed from the first carbon, then I will get 1 butane. So there are two product forms, so we have to identify which one is major, which one is minor. So based on this carbon-carbon double bond, there are two carbon substitutes, which is directly bonded to the carbon-carbon double bond, and for this one there's only one carbon substitute. So we are going to choose the highly substitute alkenes as a major product. So Sage's rules is used to determine the major product, and when there are more than one alkane form, normally major product will have a higher percentage use. So next we have another example, 2-methyl-2-butanol. So during the elimination, one hydrogen atoms and the OH group will be removed. So the hydrogen atom, first I can either remove from the first carbon or the hydrogen atom on the branch. So because these two, they are equivalent, so either I remove from this hydrogen or this hydrogen, I will get the same product, which is the carbon double bond will be on my carbon 1 and carbon 2. And then I can remove, okay, another way of elimination is I can remove the hydrogen from the third carbon. So when the hydrogen atom is removed from third carbon and the OH group, so the carbon-carbon double bond will appear on the second and third carbon. So which I will get 2-methyl-2-butane. So these are the two alkanes from the elimination. So now how can we determine which is major and which is minor? So it will depend on the number of substitute which is bond to the carbon-carbon double bond. So for 2-methyl-1-butane, I have two substitutes, so it's di-substituted alkene. And for 2-methyl-2-butane, I have 1, 2, 3 substitutes, so it's tri-substituted alkene. So tri-substituted alkene will be my major product, and then 2-methyl-1-butane will be my minor products. Here are a few more exercises. So the dehydration of alcohol and predict the major products. So I can remove one hydrogen and the hydroxyl group from this carbon to get a double bond here, or I can remove the hydrogen from this carbon and the OH group to get another double bond on my first and second carbon. So the possible products will be 2-butane and 1-butane. So now we need to identify the number of substitute which is bonded to the carbon-carbon double bond. So 2-butane is major because I have two substitute, and for 1-butane I only have one carbon substitute which is bonded to the carbon-carbon double bond. And then next one, I can remove the OH and one hydrogen from this carbon to get the double bond here, or I can remove the OH and one hydrogen from this carbon to get another carbon double bond at this side. So I can get two products which are 2-methyl-2-butane and 3-methyl-1-butane. So the 2-methyl-2-butane will be my major product because I have 3 carbon substitute, and 3-methyl-1-butane only have 1 carbon substitute. So the highly substituted alkane will be the major product based on Sage's rules. And for exercise C, so I can remove one hydrogen atom from this carbon or this carbon, so you are going to get the same alkane which is on the carbon 1 and carbon 2. Or I can remove one hydrogen from the third carbon, so my double bond will be on the second and third carbon. So the dehydration of 2-methyl-2-butanol under the concentrated sulfuric acid and heat, I will get 2-methyl-2-butane and 2-methyl-1-butane. So based on the substitute, this carbon-carbon double bond have 1, 2, 3. Okay, it has 3 substitute, and 2-methyl 1-butane only have 1, 2 substitute. So 2-methyl 2-butane will be the major product, and 2-methyl 1-butane will be the minor products.